Welcome back, everyone. This is SER 321, Principles of Distributed Software Systems. And I'd like to talk in this session about externalization and serialization. Same thing. And this is Unit 4. All right, externalizing objects into and from a running program. So let me reference the readings for this section. The 4th edition Java Networking Programming. 4th edition, Chapter 2 covers this material, and then also Java Network Programming and Distributed Computing in Chapter 4, especially Section 4.5 covers the material. There's an implementation. We're also going to talk in this section about JSON, which is a common form of JSON stands for JavaScript Object Notation, and it is a textual format for creating objects, textual for serializing objects. And we're going to look at both C++ and Java use of serialization to and from JSON as well. So the class notes cover all that material, actually cover some other stuff, but especially the basics of Java serialization. And there is also a lab exercise for this one, Java and C++ serialization. And this is, again, building upon the semester-long project. In this assignment 3, you'll be serializing the media library that you created in both Java and C++, serializing it to and from JSON. Pardon me. So let's go ahead and take a look. I'm going to go ahead and go to the PDF for serialization, and let's see if I can't make it big enough here so that you can see it better. So at the very beginning of this PDF file, it introduces externalization and serialization, and actually it gives you another reference aside from the books. And this one is at the Java tutorial under the Essential Classes section of the Java tutorial. There is a section on basic I/O, and within that is a section called Object Streams. So our outcomes are to be able to use Java's APIs and classes in order to do serialization in Java, and also be able to move an instance of an object from one Java virtual machine to another. We're not going to do it by a network, although that's coming up in another week. We're actually going to be doing it by a file. So we'll send it out to a file. So there again is the readings from the textbooks. In this section, there are a couple of three example programs that we're going to be going over. One of them covers the basics of serialization in Java. Another one shows how you can serialize to and from XML. And then the third one shows you how to go to and from JSON, both from C++ and from Java. So, excuse me, the serialization in Java is binary serialization, meaning that it doesn't produce a text file or even a text stream for that matter. So in fact, there's no, well, not just because of the fact that it's binary, but there's no interlanguage capability with Java's built-in serialization. Although it is platform independent, you can't use Java serialization and conveniently deserialize into another language unless you go and decode their binary and manually reconstruct the object to and or from in a different language, which is not a reasonable thing to do. So let's go ahead and take a look at, first of all, I want to spend a little bit of time talking about the Java virtual machine, because understanding the Java virtual machine helps quite a bit in terms of understanding what we're trying to do with virtualization or externalization. So the Java virtual machine this is essentially the Java command. I've called it in class the Java interpreter before. So in fact, what happens is if I have a program called test.java, I send it through the Java compiler. It produces a bytecode representation of test in a .class file. That that .class file gets loaded by means of the class loader into the Java command, right? So the top green thing here is the Java C command. and the bottom green horizontal one is the Java command, the Java virtual machine. The Java class library and then any other classes that we want to load and test.class get loaded into the Java virtual machine, and then on top of the operating system, those things run. All right, well, that is this part right down here. The bottom green and blue rectangles represent the execution of a Java program. In this case, it's the main program that's in test.class. Now let's take a look in a little bit more detail at this bottom green Java virtual machine. What it has inside of it, there's lots of things within it, but included in it are a class loader, a bytecode verifier, and a security manager. And the security manager, hopefully we'll talk about in more detail later on in the course, but in fact the bytecode verifier and the class loader are fairly important from the perspective of an executing Java program. So when a class file is loaded, the bytecode verifier actually makes sure that the bytecode is in a valid format. This is to allow multiple Java Cs produced by different vendors to work with one or more Java commands, Java runtime environments. So a Java runtime environment is designed in such a way that it may not know who produced the Java C or the .class file, so it has to check and make sure that to the extent that it can, that it's a valid .class file. So the runtime environment is important from the perspective of serialization, because in fact, if I try to serialize an object, deserialize an object, so suppose that I serialize my media library to a file, and then another program tries to deserialize it. So in fact, that other program may not have, it's going to bring in an object input stream, and that other program may not have already loaded, in this case, the media library and media description classes. So in fact, the bytecode, not the verifier, the class loader may need to use the class path that we've defined to go out and load the class. And we're going to find that in maybe not the next section, but the section after it, the first distributed technology we're going to look at, Java RMI, a very straightforward approach to distribution, actually is based upon serialization and the ability to actually deserialize and serialize objects. And we'll find that we can pass from one machine to another machine anything that's serializable in Java, along with primitive data as well. So that's two of the three things that can go back and forth. So let's go ahead and talk about serialization from the Java perspective. And in Java, Java input and output, you may not have looked at it in much detail, but it's all stream-based, meaning that just like you can think about it as a river, a stream, water that flows by, data that flows by, flows in a stream. And so all input and output is generally stream-based input and output. And in Java, there are three basic kinds of streams. There's a buffered stream, which does exactly what you think. It reads in, or depending on it's an input or an output stream, reads in a certain amount of data, buffers that data until the program works its way through the buffer, and then it gets another buffer and works its way through the program, works its way through that buffer. So the notion of buffering input and output is taken care of by a buffered stream. And buffered streams are typically accessed one byte at a time, right? Or arrays of bytes. So they're chunks of data that one looks at. The next type of stream is what's called a data stream. And a data stream is designed within Java for doing input and output of primitive data. So it lets an application write at the level of primitive data objects, Java data objects. So we've talked about that as well. Int, Boolean, double, char. Those are all examples of primitive data in Java. And then, if you will, the highest level sort of a stream is what's called an object stream. All right, so now think about when I create an object stream and I want to write an object to a file, that's serializing, that's externalizing, getting an object that I've created in my program, my Java program, executing Java program, out of the program to persist it, in this case on a file, or we're going to be sending it across a stream, a socket, connection to another program running on presumably a different machine. So the object stream, and these are in java.io, object output stream and object input stream, are the mechanism for doing serialization and deserialization. And honestly, it's almost as easy as that. We define where we're going to, we get a stream, an object input stream or an object output stream, and we can throw objects into that stream under the assumption that that object implements the interface java.io.serializable. All right, so java.io.serializable is what we call a marker interface in Java. If you haven't learned about interfaces, the interface is a mechanism in Java to say it's kind of like an H file in C or C++, meaning that it defines exactly that, the signatures of methods. Generally the signatures of methods. We can have other definitions in there as well, but it means that, in fact, here's the interface between two different pieces of software, one that I write, one that you write. So there's a provider, and then there's also the user. So as long as the provider implements the interface and the user uses only the interface, then in fact they're able to talk to each other. The java.io.serializable interface is an interface that classes implement to indicate that they want to be serializable, that the instances of that class are serializable. And we don't have to implement any methods in order to implement the interface. That's why it's called a marker interface. There's no methods that one has to implement in order to be serializable. So actually, before we go any further, so we can create classes that implement Java IO serializable, but I want to actually also point out that there are lots and lots and lots of classes that are already defined in the Java API that are also serializable, that are extremely useful classes. So let me just go ahead and go to, if you have not yet bookmarked or downloaded, let's go back to the home page here. Under resources, down past the development and deployment environment, here's a section on Java execution environment and documentation. There's a tutorial, the Java tutorial, and then here's a good place to download Java SE. Excuse me, there's also a documentation link. And in particular, this one is very important. It's the Java SE API documentation. And this actually links to version 8 of the API documentation. And see if I can boost it up a little bit. If you have never seen this before, you should bookmark it. You can actually download this, the HTML file version of this, or actually there's also a PDF version of it, and install it on your machine so you have a local version of it instead of having to use this link. Here's why it's very useful. This large panel on the right-hand side will give you the documentation, complete documentation of a class in Java, and the smaller window in the upper left are all the packages that are available in the standard API, and it's huge. As I scroll down through here, you can see Java, JavaX, and so forth. Every time I select a package, it shows me all of the interfaces and packages and exceptions in that class. So let's go to java.util, which I hope you've had some experience with. And just for the fun of it, so here are interfaces in java.util. These are all interfaces. When I select one of the interfaces, it shows me the specific documentation for this interface. And in particular, it shows me all the methods that are part of the interface. In this case, there's only one method. It's the update method. Let's go to, I'm sure everybody has seen a java.util vector. So here is the vector class in Java. And when I select it in this panel, right, remember I've already selected java.util up here. Then I go down and pick the class that I want to look at the detailed information on. So I've selected vector, and it shows me all the information about the vector class. So the important thing is this, all right? Notice that all implemented interfaces, Java .util.vector implements the serializable interface. It's also clonable, iterable, collection, list, and random access. But in fact, the important thing is that it's serializable. So that means that if I create an object output stream and I have a vector, as long as that vector contains objects which are also serializable, which means they implement the serializable interface, then in fact I can export, externalize that object, frankly, with one line of code, and we'll take a look at it here in just a minute. So to see how extensive um, serializable is within the predefined API. Here's a hash map, another very commonly used interface. And notice that it's serializable. Actually, with vector, I also ought to go to an array list. So array list is very similar to a vector. We'll point out the difference when we start looking at threads. But an array list is also serializable. A hash map, all right, it's also serializable. And then in the same way that array list and vector are related, hash map and hash table are related, meaning that in fact they provide almost the exact, or they do provide the same functionality, but there are a couple of interesting twists to the way they provide it. Hash table is also serializable. So if you take a look at all of the collections in the collections API, almost all of the utility classes are serializable. And then when we take a look, actually, another interesting aspect is that when we look at swing, Java x.swing, all of those components, these are the components that you can put into a user interface, the buttons, the trees, the text fields, and so forth. They're all serializable as well. So quite literally, you can externalize, serialize a Java user interface to a file or across a network, and then deserialize it on the other end, and poof, up will pop up your user interface, as long as it's all serializable. Okay, so serializable is very well ingrained within the API, and anything that is serializable, you can write to an object output stream or read into an object input stream. So let's go back, not to that one, let's go back to this guy. Oh, I'm sorry, I want to go back to the, so streamifying, let's take a look at an example. So if I define a group as a user-defined class in Java, and that group contains a vector of users. That sounds a little bit like a media library that may contain a vector or a hash map or a hash table of media descriptions. In fact, if I allow them, if I implement serializable, then in fact that group will automatically be serialized, all of the vector, including all of the users, providing that both group and user are serializable. Right, so no methods need to be implemented. All I need to do is to say I implement Java IO serializable. So if a group, for example, in this case, I think the group consists, we'll see an example here in just a minute. The group consists of a string object and maybe an int object. So in fact, those are serializable as well. And we didn't look up string, but in fact, if you take a look at it, you'll see that a Java string is serializable. So here's some example code that shows you how to create a file output stream to a given a new file output stream based upon the string, and then object output stream based upon that file output stream, and then writing something to s.writeObject, and writes two different objects to it, then flushes it. So let's go ahead and take a look at this group serialize.jar example. And I'm going to switch and do this under, there's actually three different examples here that we want to look at. So jar, so now I'm running under Debian Wheezy on my VirtualBox, xf group serialize.jar, and it creates a folder called group serialize, and within that folder you'll find two things, build.xml and source. Remember, build.xml is essentially the directive file for Ant. And then within the source directory, you'll find 4 different files. Group is an interface. Group impl is the implementation of the group interface. And then there is also a user. So the idea is that a group is a collection of users. So I'm going to create some user objects, put them into a group, add them to a group, and then I'm going to serialize that group to a file. So group file serialize is the main program, and it does the serialization. So let's go ahead and execute it. Ant. If you just do ant, it says here are the targets. Ant execute. And you can see what it did was to prepare, the target prepare, followed by the target build, followed by the target execute. So the build was a Java C. The prepare actually made our classes directory for us. And then execute actually invoked the Java command, and the Java command actually had some output. The Java program generated output, so that gets labeled as Java as well. So this says server is ready and waiting to export a group. It's not really a server, but it's close enough. Server's done exporting the group. Group administration, that's the name of the group. And so it read it back in, and it found Tim, Joe, and Sue were members of the group. So now if you take a look at what's in our project folder now, we have build.xml, we have classes directory, which contains the .class version of all of the source code. And we also have this thing called admin.ser. And admin.ser is a file that got created to externalize this administration group. Right? So we created an administration group object with Tim, Joe, and Sue in it as the users. And then we externalized, we serialized that to a file. So let's actually read it from the top down. In order to do that, let's go to, we're going to go first to the group file serialize, the main program, and update this. So I'm in Emacs now. And so here is, it's in package SER321 serialize. Notice that it imports object output stream, file output stream, object input stream, file input stream, vector, and enumeration. So let's go down and take a look at the code. So here's all that's in the group file serialized class is a main method, public static void main. So it creates a group object. This is an interesting thing you may not have seen before. Since group is an interface, I can create an object, and as long as whatever the class is of that object, as long as it implements that interface, the group interface, I can just call, in this case, admin, a group instead of calling it a group impl. And we'll see in a minute that group impl implements the group interface. So I create a new group impl. This is the administration group. That's the name of the group. And then I create actually, so in the group, there's a method to add a user to a group. So I have to give it the information for creating a new user, and it creates a new user and puts it in there for me. We'll take a look at that in a minute. So now I have created an admin group, and I've added 3 users to the group. I now create a new output file, admin.ser, an object output stream based upon that out file. And now I do os.writeObject admin. Right? So since admin is serializable and os is an object output stream, I can write the entire admin group. In this case, it's not huge, but it could be, by one statement. Right? Write object admin, and then os.flush and os.close. In Java, you don't need to close. If you create a file object in Java, you don't have to close it. Matter of fact, there isn't even a close method for the file object. File object is really nothing more than a path to a file. It's the streams that actually have to be closed. So object output stream is a new object output stream from a file output stream to our out file. Okay, so after writing out admin.ser, I printed out server is done exporting the group, and now I create an input file. I actually could use the same file, but that's all right. Object input stream is a new object input stream from our in file, and group G is in.readObject, right? So there's my input stream. What's out there in the file is a group that has several users in it. It's a vector of users. And so I read that in, and then I cast it to a group impl. All right, so that actually reads in that object, and it creates a group impl object for me, which I'm calling the group G. And then I actually get the usernames. There is a group method called getUsernames, which returns from me a vector of strings. I go through it and print out, and that's what gave me the Tim, Joe, and Sue, right? System.out.println, e.nextLine, right? So the group received includes Tim, Joe, and Sue, comes from this iteration. Okay, so no, we haven't done, the other thing to point out in this program is to look at group impl. And group impl has a string which is the name of the group. In this case, it was administration. And it also has a vector of user objects, right? Which is a new vector of user objects. And notice that group impl implements both the group interface and the serializable interface. So now on the bottom, let's just go ahead and bring in group.java. And I'm just going to go down here to the interface header. And notice that it's public interface, right? If you haven't seen an interface before, it looks a lot like a class, except it's an interface instead of a class. And instead of having bodies for the methods that get defined, this is called a signature. Just tells me what are the arguments that go into a method, the name of the method, and what is the result of calling that method. The other interesting thing to do, actually I was going to do this, but I didn't, is to include, these are called Java doc comments. We looked at the Java docs for the Java API. Well, they're all generated by the source code of these things, essentially of class and interface definitions, right? So in fact, JavaDoc is a tool that will generate HTML or other stuff if we want it to, based upon the comments that exist within it. And we'll take a look at that. If you haven't already seen it, we'll look at that a little bit later on this semester. The interface group doesn't implement interface, all right, or doesn't implement serializable. An interface can extend an interface, but it can't implement because it doesn't do any implementation. It just declares methods. So the methods in a group are to get the name of the group, to add a user to the group, and to get all the names of users that are in the group. And I guess to ask whether or not a given string and password are members of the group. So even though it's a string, if it was obfuscated, whatever, you could view this as an authentication mechanism. Okay, so the only other thing that we haven't looked at is user. And notice that a user object is a very simple object that does nothing more than check whether or not a user is user's ID matches their password, user's ID and password match an argument, and to get the ID of a given user. So there is a constructor which takes in the ID and the password. More importantly, the only thing really important about this class is that it implements serializable. So my user is serializable. The group is group impl is serializable. So then, in fact, I can create a group and serialize that group through an object output stream. or read it in through an object input stream. Nothing more. Let's leave it at that. Let's go on and actually I'm going to switch back here. So user-defined classes, we just implement serializable. We're going to come back to serial version. There's another interesting thing about serialization after the fact. After Java was originally defined, it became important to do XML. And so Java Beans was a mechanism added on that allowed us to serialize to and from XML. So there's an XML decoder and an XML encoder. And anything that is a Java Bean, I'll point it out when we read the code. Here are a couple of references to Java Beans. Actually, Java Beans are very useful in web application programming. So here's an example that does almost the exact same thing, but it serializes it to XML instead of serializing it to the binary. I guess one thing I didn't do, I'll go back here to this guy, cat. All right, remember cat prints out the contents of a file. If I cat admin.ser, you can see that it's primarily a binary file, and it actually does have some strings in it, but it's binary representation. Right? And these crazy symbols that you see when you cat it or print it out are actually binary that gets encoded or gets the corresponding ASCII representation of it gets printed out. All right, so I'm going to clean this and clean. And now let's go ahead and look at the XML example. So again, source directory, and it has actually, so we're just serializing a user, user XML, and let's go ahead and ant. We'll execute it first and then read it. And execute. Java compile and then execute. So ready to export a user. Done exporting a user as XML to user.xml, and then it reads it back in, and the user's Tim Lindquist. So cat, well, let's do ll. There's a listing. So now we have classes directory that has a compiled version of those .java files and user.xml. So cat user.xml. So now it is text. And when you serialize to XML, it indicates java.beans.xml decoder. That's the one who did the encoding and decoding. And it shows the Java version. And then we have an object element. The object element tells what class that object is. SER321 serialize user class. And a property which is the first name, which is a string, property which is the last name, which is a string, property which is the user ID, and the user password. All right, so in fact, these are the components that make up a user object, and let's go ahead and take a look at it in the code. It's not enough to just get these things to run. The whole idea of doing this is to look at the code. So here is a user, and the interesting thing about a Java Bean, any class can be a Java Bean, provided that the following hold. All of the fields within the class have to have getters and setters, and the names of the getters and setters correspond to the names of the fields. So there's a user ID field, consequently there is a get user ID and a set user ID. Right, so we have a getter and setter for user ID, we have a getter and setter for user password, and so forth. All right, so that's one of the criteria for having a class be a bean class. The other criteria is that there be a parameterless constructor, so that in fact when the decoder finds a serialized XML that it needs to rebuild one of these user instances, it will first call the parameterless constructor and create an instance, and then it will, as it encounters each of the different XML items, it'll set user ID based upon, right? So it knows what method to call based upon what's the contents of that XML file. Right, so I've specially constructed this user.java so that it is a bean class. And now let's go ahead and take a look at using the XML encoder and decoder is very similar to using object input stream and object output stream. I create, in this case, we do out first, file output stream, XML output stream is a new file output stream, user.xml, and XML encoder, new XML encoder that works on this output stream, XML output stream. So then I just say encoder write object Tim, and I created Tim as a user up here. All right, and then in order to read it back in, file input stream, user.xml, XML decoder on that file input stream. User new Tim is decoder.read object, cast it to a user object, and then I've got my user read back in. Now, presumably, same thing with the last example. These may be different programs, or at least different instances, different executions of programs that want to recover. So, for example, with the media library, you may serialize the state of the library. If you don't want to use a database, for example, you may serialize the state of the library so that when the server comes back up, it's able to recover its prior state by deserializing. A good example of using serialization. So with one statement, you can write out the whole state of the server before it closes or before it ends, and then with one statement, you can reinitialize the entire state of the server when it starts back up. All right, so that's the second example. Now there's one more example we want to look at, and that is JSON. So JSON stands for JavaScript Object Notation. And what is the importance of JSON? Well, it is one of many different. XML is one of them. JSON is very interesting because it is text-based, and yet it is very terse, very short. So if you use XML, XML tends to be kind of verbose. And when you're doing a lot of serializing to and from, especially complex objects, the amount of space that it takes to serialize, or the size of the stream, however you want to look at it, the length of the stream, actually is fairly extensive. Well, JSON is extremely simple, and that's one advantage of JSON. And as I mentioned, JSON is text-based. There's actually a standard that has a binary-based version of JSON, which is actually even more terse than the text-based version. So the other advantage of JSON is that not only has it been used by JavaScript, but lots of other programmers who use lots of different programming languages have provided support for JSON. Especially the most popular ones, certainly for Python, for Java, for C, C++, for Objective-C, for Swift, and several other languages. There are interfaces, packages available, if they're not built into the language, packages available for doing JSON serialization and deserialization. So let's first look at what is a JSON object. How do we define a JSON object? Here is a link to a Wikipedia page on JSON, and it's well worth looking at. At its simplest level, these 1, 2, 3, 4, 5, 6 things are the 6 things that can be JSON objects. A JSON object can be a signed decimal number, meaning that it can be a double or an integer. So minus 125.32 plus 125, or just 125, are examples of signed decimal numbers. So a signed number is a JSON object. A string literal is a JSON object. So I am a string literal. A string is a JSON object. A Boolean value is a JSON object. So true and false are JSON objects. And then we can take JSON objects and we can compose them together, right? We can make a composite data. In this case, it's homogeneous. Well, it doesn't have to be actually. We can make an array of JSON values, JSON values. So left bracket, right bracket denotes an array where each of the elements of the array are separated by a comma. So array open 122.55 is the first element in the array. A string, another string is a second element. The third element of the array is an array, a JSON array, which has a string, right, a subarray, and a Boolean value. And then the last element of the highest level array is false. Right, so that makes up a JSON value. So a JSON object can be an array of any JSON object, and then there is essentially a map, a hash map, which is called an object. And it's like in actually hash map would be better than just a map of a string and then a JSON object. So if we use curly braces instead of square braces, then this represents another kind of JSON object in which each of the elements has a key. All right, so the first element in this JSON object is key JSON RPC. The second element is a string. Don't confuse it with a number. All right, it wouldn't have quotes if it was the number. So JSON, so the key colon and then whatever the value is. So JSON RPC. There's a reason for this example. And then next is method. All right, so the key's name, the key is method, and the value of that is subtract. And then the next element in this hash map is parms. And here we have an array. So in this case, the array has two integer values, 42 and 43. And then the last component is an ID. All right, the key is ID, and the value in this case is 1. Right, so an object, which is enclosed in curly braces, can also be a JSON object. And then a null value can also be, right? So another valid JSON value is null. So here's an example that does JSON, and we're again using the group as an example. So let's go back and extract it and execute it. Group JSON. So we have group serialize and group JSON. And in group JSON, we now have something new, which is the live directory. And thus in the live directory are two things, ant libs, which we've already hopefully gotten squared away on yours, so you can use ant, same thing that you've seen before, but also json.jar. And json.jar is a jar file that contains a set of classes that augment for us the predefined classes for Java, allowing us to do serialization to and from JSON. So this is necessary. I'll show you in just a minute in the source code. In the source directory, we have two subfolders, CPP, which is the C++ program, and also Java, which is the Java program, right? So JSON allows us to serialize to and from different languages. So we're going to JSON serialize from Java and then reconstruct it within C++. So if I do ant, it says the targets I know about are build Java, execute Java, build CPP. So let's do ant, actually I should also point out the readme.txt file. Readme.txt explains what I'm going through here, shows you how to execute it, and it actually gives you a couple of different references, right? So if you haven't apt-get, sudo apt-get install JSON CPP, then in fact this example won't work, and that's taking care of C++ JSON, and then that's used in the C++ program. And then the same thing, it also has a reference to the implementation. It's an open source. Doug Crockford did this one in the live directory of that JSON. So ant So take a look at the readme.txt file and also read the code, build.java. So there, that's been compiled. I should have done ant execute.java. I think it's just execute, but maybe it's execute.java. So when you execute Java, it's going to, again, we have the same group, same people, Tim, Joe, and Sue, and administration group as a JSON string. So this shows you the JSON string that administration group is, and it writes it out to a file, and the file is admin.json. I think it also does regular Java serialization as well. So now if I do a listing, you can see I have both admin.json and admin.ser. The interesting thing from my perspective is, remember that we said that so admin.ser should be exactly the same as the one from the previous example using Java's built-in serialization. Notice that it takes 404 bytes, where the text-based, text is supposed to be more volume, only takes 155 bytes. So if I do cat admin.json, then you can see here is the JSON object that was written out. So now I've already done, I must have already done build the, oh, I don't think I did, ant build.cpp. So there it compiles the 3 files and links it, and now in the bin directory we have group JSON. So you have to run the Java one before you run the C++ version of this. The C++ version reads in group.json, builds a C++ group object, which has C++ users within it, and then it serializes it back out. So it shows you how to use libjson CPP in order to do that. So if I do /bin group JSON, you can see that it done initializing from admin.json, and then it found the users, Joe, Sue, and Tim. User Joe has a password Joe word, and so forth. So now let's look at what's left. So it created, so it read in, the C++ program read in admin.json, and it created admin from cpp.json. So if I do cat admin from cpp.json, there's an option in creating a string from the libjson CPP, C++, that will pretty print for us. It'll create a string that has, in this case, line feeds in it, or return characters in it. So you can see the nesting, right? So in this case, the JSON object, right? There's the beginning of it. Down here is the end of it. The first key is Joe, and the value is value of Joe is a JSON object whose first key is user ID and second key is user password. So there's Joe's object. Here is Sue's object, and then here is Tim's object. And notice that we also have a key name, and the value of that one is administration. All right. So the code shows you how to read in and write out from both C++ and Java these JSON, read in and write out JSON. And it should be no surprise to you that the next assignment is actually to do, let me go to home and bump it up. I don't need to bump it up. Under class schedule, we're in Unit 4. The lab exercise, C++ and Java serialization to and from JSON. And this one asks you to redo your media library and media description classes in both Java and C++ to be able to be initialized from a JSON file. And here is a JSON file that you can use for it to do your initialization. So your program should, both Java and C++, should be able to read in this JSON and initialize your library from that JSON. So it shows you what methods are recommended for you to implement in order to facilitate that. And depending upon whether you're in the online section or in the face-to-face section, these things are due at different times. One thing I want to point out to you that will be useful is, let's see. Here are the Java docs for Crockford's implementation of JSON. So org.json and org.json.zip, the package json.zip, you don't end up having to use, but you will have to use all of the, not all of them, some of the classes in org.json. All right, so here's a JSON object, and in fact, there's also a JSON array, which are what you would expect they are. And it provides the ability to read and write to and from, right, to create JSON strings and to read in JSON to create one of these objects, to get elements out of the object. Okay, so I think what I'm going to do is leave it at that for the discussion. There is one more thing I want to look at. So we can also do customization. So we can implement, if we do Java serialization, we can write our own write object and read object methods in our class that'll allow us to create whatever format we want for serialization. As long as we do both of them, read object gets called for deserialization and write object gets called for serialization. So Java will call our methods. And consequently, we can put whatever we want into the stream. The last thing I want to mention is this thing called class versioning. In Java, imagine the situation where you take your media library, serialize it out to a file, and then you go and recompile media library and make some changes to it. Well, Java has built into it a protection mechanism that would allow that recompiled new media library to not be able to read an older version, serialized version of a media library object. And it is called the serial version. Java provides JDK provides a tool that allows you to find out what the serial version is. So every class that Java creates has within it a serial version UID if it's a serializable object. And you can actually override. So the idea is if you use this serial version tool, it will provide for you a declaration that you put into your class. And then no matter how many recompiles you do or whatever changes you make to that class, it'll still serialize from older versions. Now, you may have made changes to the class that mess up so that this deserialization will either be incomplete or it will actually fail because you've made some changes to things that were assumed in the serialized object. But it does provide a mechanism with a serial version UID to be able to provide for compatibility of newer versions of a already compiled serialized object. All right, let's leave it at that. So that is the end of the material for the section on 4. Go back to the schedule. Unit 4 on serialization.